that first sip of water you drank this morning? It probably felt ordinary. But what if I told you the water in that glass could be billions of years old? Old enough to have once been inside a dinosaur. That sounds kind of wild, but it's true. Earth's water is part of a closed system. The same water moves through oceans, clouds, rivers, animals, plants, and people over and over again. So that morning sip wasn't something new. You were drinking something incredibly old that has been recycled countless times before.
Exactly. But in human societies, recycling doesn't happen on its own. It depends on an invisible system known as wastewater treatment. Wastewater treatment is a set of engineered processes and modern systems designed to remove physical, chemical, and biological contaminants. The goal is to make the water safe, either to return to the environment or for other human purposes.
With over 8 billion people on the planet, this isn't just a local system, it's global. In large cities, wastewater is treated at massive municipal facilities that serve millions of people. In Phoenix, that means managing a network of 5,000 miles of sewer lines connecting 2 major treatment facilities, handling wastewater for more than 2.5 million Valley residents every single day.
Wastewater reflects patterns of daily life, economic activity, and urban infrastructure. It includes more than just water from sinks and toilets. It's water that has been moved through our human systems and contains organic waste, chemicals, nutrients, microorganisms, and byproducts from everyday activities like cooking, cleaning, manufacturing, and sanitation practices. In other words, wastewater reflects how city life functions. And once humans began living in cities, treatment stopped being optional. It became essential.
For most of human history, contaminated water was one of the leading causes of death. Diseases like cholera spread through water and killed millions.
Everything changed in the 1800s. During a cholera outbreak, John Snow traced the disease to a contaminated water pump. When it was removed, the outbreak slowed. For the first time, water quality was clearly linked to human health.
There was not a lot of wastewater treatment, or almost nothing, like 100 years ago, 150 years ago, and the life expectancy was like 40 years. The medical field helped a lot, but the other impact is wastewater treatment. So now we live up to 80 and more.
From there, treatment advanced quickly with the development of filtration, chlorination, and biological systems that use microorganisms to break down waste. These systems didn't appear all at once. They evolved through scientific research, trial and error, and technological innovation. From early filtration experiments to the development of activated sludge in the early 20th century, and to today's advanced oxidation and membrane systems. What we see now in modern cities is the result of decades of interdisciplinary research shaping increasingly efficient and scalable solutions.
And that connection between water and health hasn't gone away. Poor water quality is still directly linked to human illness. Contaminants in water systems can contribute to gastrointestinal disease, neurological conditions, and in some cases, long-term exposure has been associated with increased cancer risk. Wastewater treatment, then, isn't just about infrastructure. It's a public health system. The quality of treated water has real consequences for human bodies, communities, and long-term health outcomes. Today, wastewater treatment exists as vast, interconnected infrastructure, but systems like this can be hard to understand at once. To see how this technology actually works in practice, we need to narrow our focus.
We're in Phoenix, home to Arizona State University, a fast-growing city recently referred to as the Silicon Desert, shaped by water scarcity, rising demand, and an arid climate. Phoenix manages one of the largest municipal wastewater systems in the country.
It can treat up to 230 million gallons per day of wastewater that it receives from 5 Valley cities. So this facility is co-owned by Phoenix, Mesa, Tempe, Scottsdale, and Glendale.
Wastewater treatment is built on core principles from chemistry, microbiology, and environmental engineering. To understand the system, we need to break it down into stages. The first stage is pre-treatment, where large physical objects like plastic bags, wipes, and sand are removed to protect equipment downstream. Primary treatment then separates solids from liquids through settling and coagulation, which relies on chemical reactions that cause particles to bind together. Secondary treatment uses microorganisms called activated sludge to break down organic material as food, converting it to less harmful byproducts. And tertiary treatment applies advanced methods like UV radiation and oxidation to disinfect water and make reuse possible.
These technologies make it possible to safely reuse treated wastewater for irrigation, industrial cooling, groundwater recharge, and environmental restoration. Not all recycled water is treated to the same level, and it doesn't need to be. The level of treatment depends on how the water will be used. For example, Water used in agriculture or industrial cooling may go through secondary or tertiary treatment. But for uses like groundwater recharge or even drinking, water must go through much more advanced purification to meet stricter safety standards.
At the highest level, this process is called advanced water purification. Some even refer to this as toilet to tap. In these systems, wastewater is treated using technologies like microfiltration, reverse osmosis, and advanced oxidation to remove nearly all contaminants at the molecular level. The result is water that can meet or even exceed drinking water standards.
Like right now, we're talking about advanced purified water. We're seeing this first plant as a large-scale demonstration facility, right? It's going to be a facility that's going to allow us to bring ASU students, our elected officials, our customers, anybody and everybody that wants to learn about advanced water purification, we will bring them to Cave Creek with the goal to be able to have them see the treated wastewater that's going into the advanced water purification facility. Because I think when people see how clean it is before it even enters the advanced water purification facility, that just blows people's mind. They think of wastewater as like this horrible thing and it's all sludgy and full of poo and all this stuff. But even untreated wastewater, when you look at it, when you pop a manhole, it's mostly water. So I always have to remind people we're just cleaning the water, right? There is no new water. It's all the same water.
This mindset of reuse is what makes cities like Phoenix possible. The Palo Verde Nuclear Generating Station, the largest nuclear power plant in the country, is the only one in the world cooled entirely by treated wastewater, receiving roughly 65 million gallons a day piped from Phoenix's 91st Avenue treatment facility and generating electricity for 4 million people in 4 states.
These systems are under pressure. Climate change, population growth, and industrial demand are pushing wastewater systems to evolve. Across the water sector, engineers and utilities are rethinking what treatment plants can be. Instead of static facilities that react to problems after they happen, the next generation of wastewater systems is being designed to be adaptive, data-driven, and predictive. AI systems can now analyze massive amounts of data from treatment plants, adjusting chemical dosing, optimizing energy use, and detecting anomalies in real time.
In cities like Phoenix, technological advancements can equip municipalities with decision-making tools that make treatment systems run more efficiently, more sustainably, and for less. This means the future of wastewater treatment isn't just about cleaning water, it's about collaboration between technology and governance to build more resilient systems.
How can scientists and policymakers collaborate in this? They've been doing a pretty decent job, as far as I can tell, with that collaboration where the regulators are putting the brakes on and really slowing down, in a way, the folks who are really in love with the technology. And I do have to say, there are a lot of folks who are really in love with advanced water purification technologies because they're so effective. And because, this is where it's so interesting from a waste perspective, you can actually start mining your waste supply and turning it into a potential revenue stream.
Universities play a key role by researching new treatment methods, testing solutions at scale, and training the next generation of engineers and water professionals.
At Arizona State University, research centers are developing new treatment methods and adaptable solutions for real-world use. The Global Futures Laboratory and the Sweetie Center for Environmental Biotechnology are engineering new microbial communities to break down waste, creating novel methods of recovering nutrients and energy from waste, and are actively developing the new sensors, tools, and systems to support innovations in the space.
Even with these advancements, there are still critical gaps. New chemicals are constantly being introduced into everyday products like pharmaceuticals, personal care items, and industrial compounds that existing treatment systems weren't originally designed to remove. These are often called emerging contaminants, and in many cases, the technology to fully eliminate them either doesn't exist yet or is too expensive to implement at scale. But even with these advances, wastewater treatment still faces one of its biggest challenges. Not an engineering problem, but a psychological one. For many people, the idea of reusing treated wastewater triggers what some call the yuck factor. And it's not that the technology doesn't work, it's that trusting it requires us to rethink how we understand cleanliness, risk, and where water comes from.
But in reality, water has always been reused. Long before treatment plants, sensors, or AI, the same water has been moving through Earth's systems. What wastewater treatment does is make that natural cycle safer, more controlled, and more reliable for modern life. So when you think back to that first sip of water you drank this morning and what happened to it after it left your body, It might feel ordinary, but behind it is a vast, invisible system built over centuries that protects public health, supports cities like Phoenix, and makes modern life possible. In the end, wastewater treatment isn't about making clean water. It's about learning how to live responsibly in a closed system and whether we trust ourselves enough to do it well.